Hi, my name is Amanda Rosa. I'll speak about radiation and personal monitoring. So the first thing I will be speaking about are the requirements. So your dosimeters are issued just to measure and record the amount of occupational radiation dose the individual will receive by staying federal regulations. Your dosimeters are required to be issued when an individual is likely to receive greater than 10% maximum permissible dose. Down here is a chart showing you how much you should be receiving annually. Whole bodies 50 millisieverts or 5 rem. The people who should be using dosimeters are people who have access to x-ray machines, fluoroscopy, certain sealed and unsealed radioisotopes, exposed to other sources of gamma or high energy beta radiation. Your placement of your dosimeter, when should it be worn, is during a routine computer radiography, digital radiography, or conventional. How should it be worn? When you have a protective apron is not being worn, it should be worn above like your collar level. Why is it worn? And limits were set to minimize the risk of biological damage. Here's an image showing you where it should be worn. As well, if you have a lead apron on already, so it should be worn the same location, the collar level. If it's not worn around your collar level, it should be worn on the side of the body closest to the patient, which is the radiation source. For your pregnant workers, it should be around the pelvic area, shown as a third image on the bottom. Now I'm explaining different kind of badges. You have your film badge. It's been used since the 1940s and is being used in diagnostic. Your film badge consists of specific radiation dosimetry film packed like dental film. It's enclosed in a special plastic holder. The holder has an open window that has the user's name on it and various filters to identify the type of energy of ionizing radiation. They're used for about 1 month and they can be measured doses as low as 10 millirems. You have your OSL, which is your optically stimulated luminescence. These dosimeters are gradually replaced the long-used film badges. They contain a thin layer of aluminum oxide. Aluminum oxide absorbs and stores energy associated with the exposure. These are like the ones we were in school. The chips are stimulated with green light from a laser. The resulting blue light emits from the aluminum is proportional to the amount of radiation exposed. Both high and low energy photons and beta particles can be measured with this technique. Then you have your TLD, your thermoluminescent dosimeter. The material inside is lithium fluoride in crystalline form, either as a powder or as a small chip. The LIF absorbs and stores energy associated with exposure to ionizing radiation. The TLD is returned to the laboratory for processing. The LIF chips are heated. The process causes a release of visible light from the chip in proportion to the amount of ionizing radiation. The quantity of light emitted is equated. Pretty much it's just saying it's just like showing how much radiation, and it gives you that report. Then you have your pocket ionizing chambers or your pocket dosimeters. They have small ionizing chambers to measure radiation. When you're working with high exposure or large quantities of radiation for a short period of time, this is what these are used for. Gives you an immediate reading. They're very sensitive and accurate, but they're limited to diagnostic radiography. And when heated, the crystals release trapped electrons in the form of light. Then you have your Geiger-Müller, is an instrument used for the detection of ionizing radiation. Invented in 1908, it's used for detection of gamma, X-rays, alpha, and beta. When ionizing radiation strikes the tube, some molecules of the filled gas are ionized directed by the incident radiation, but it takes a long time to recover between pulses and is not able to measure high radiation rates due to the dead time. Then you have ionizing chamber Cutie Pie. It's named Cutie Pie due to the size. It's handheld chamber instrument used for detection of X-ray, gamma, and beta particles. It's a portable radiation detection instrument. Adapted for expecting an area of individual established an existing amount of radioactive material. It also provides its information numerical display in units as counts per unit, counts per second, or microröntgen in microrem per hour. It's the simplest of all the gas-filled radiation detectors. And it's used in the nuclear power industry for labs, radiography, radiobiology. Then you have your proportional chamber. It's an electrical device that detects various types of ionizing radiation. It's very sensitive to low levels of radiation. It can be used to detect alpha, beta, gamma, or neutron radiation. And And that's all.